Hi everyone, time for us to talk some more about stoichiometry today. So we're on page 2 of this lecture outline, and this is going to be our first foray into the world of the particulate diagram. And this is really a wonderful way of talking about chemistry, and I got really excited when the AP exam folks decided that they were going to make this a real emphasis for the exam. This is the way that I learned chemistry a long time ago, and it was really for me an exciting time when the College Board decided that they were going to start transitioning away from just wanting you to be able to solve math problems and to be able to explain what's really happening inside of a beaker or a balloon or a box, and to understand what the atoms, the molecules, and the particles are doing that explains the chemistry and the physical world behind the behavior that we're seeing. So we're going to look at them in a few different ways, okay? So let's start off with a really simple reaction that I think you know. That's the reaction between hydrogen gas, H2, and chlorine gas, Cl2, to form HCl, hydrogen chloride gas. And we're going to balance that by putting a 2 there. Now, let's draw the reactants over here on the left. So for the H, I can do a little diatomic that looks like that, okay? Now, for the chlorine, I'd probably draw something a little bit bigger because the chlorines are slightly larger atoms. Now, in an actual AP exam, you can't use multiple colors, but we can do it here. So I've got one hydrogen diatomic, one chlorine that's diatomic, okay? Now, what are my products? Well, I've got a HCl, and I've got another HCl. Now, it's important to note something, and this is like big time important, like I should be ringing a bell, jumping up and down, etc., etc. You need to have the same number of particles over here that you have over here. They need to match up. I've got 2 hydrogens here, I've got 2 hydrogens here, 2 chlorines here, 2 chlorines here. That's representing a balanced chemical equation. And that's a really important thing, okay? Now, let's do a slightly different one. The equation for the formation of ammonia gas from hydrogen and nitrogen. So we've got N2 plus H2 to give NH3 gas. I'm going to need to put a 2 there. I'm going to need to put a 3 there. Okay? Now, 5 molecules of nitrogen react with 5 molecules of hydrogen. Draw an accurate diagram of the reactants and the products. Okay? So, I'll do my nitrogens. One, 2, 3, 4. I got 5 of them there. Okay? Now, some hydrogens. I'll do them in blue this time. Now, size-wise, they're about the same. Nitrogen might be a little bit bigger. Now, this diagram has one problem with it, but I'm going to leave it there so that you understand it a little bit better. They would not be this organized in the box. They'd be flying all around, all over the place, okay? They would not be organized. But since this is a question about counting, I thought we better do it this way. Now, we're going to make an NH3. So, here's an N. Boom. And it's got 1, 2, 3 hydrogens, H, H, H. Now basically, I just used that, and I used that one, and that one. Now let's do another one. N. Boom. Now I've got 1, 2, 3. Not an artist here, don't worry. But it'll be enough to make sense. 1, then 1, 2, 3. Okay. Now, I can do another one. So, let's see, I need red here. And boom. And then 1, 2, 3, H, H, H. Now that's that nitrogen. And then 1, 2, and 3. You know what? I can't make any more. That's it. I'm going to have a leftover hydrogen atom. And then I'm going to have a leftover nitrogen atom. And then I'm going to have 3 diatomic, let's put it right here, nitrogens. Okay? So, it's not a perfect balance, but I can identify limiting and excess. Okay? My limiting was hydrogen. I ran out of hydrogen before I ran out of anything else. And my excess was nitrogen. Now you might be saying, wait a minute, you've still got a hydrogen left. I might have a hydrogen left, but I don't have enough hydrogen to make another molecule of ammonia. That means it's the limiting reactant. Okay, there you go. That's page 2.